let's start. Yeah, go ahead.
প্রথম যে কোয়েশ্চেনের স্টেপ ওয়ানটা আমরা প্রুভ করছি, তো এখানে সি এফ বাই
No, no,
জি
no, no, no,
জি।
no. Don't go through this. I tell you to start from Jam 2? Don't read that because that requires some techniques from Galois theory which I haven't taught yet.
ওকে।
That is actually a remarkable problem.
আরেকটা প্রশ্ন, কিভাবে ক্রস রেশিও এই কনসেপ্টটার মোটিভেশনটা এলো, মানে কেমন ভাবে ভাবনা চিন্তা করে আসা?
First of all, if you see a Mobius transform, I mean a cross ratio is a Mobius transformation. So your question should be how do we come up with the concept of Mobius transformation, right? That should be the question.
ওকে।
Basically, these are maps from the compact, the compactification of C to the compactification of C. That is from Riemann sphere to Riemann sphere. And
ইয়া।
we will, this is actually homeomorphisms of the Riemann sphere. That's thing. Okay. So how far did we go in the last day? In the last class? I think this was the last thing we stated, right? This proposition, right? This proposition was the last thing I think that we saw. We saw for any two circles, there is a Mobius transformation telling first circle to the second. And if we fix 3 points in the domain and codomain circle, then we observed that this circle was uniquely determined, right? Okay. So let's see the next thing. Let C be a circle. Now these things are very important for net, in fact. Let gamma be a circle, right? Through Z2, Z3, Z4. The points Z and Z4, Z and Z star in C infinity are said to be symmetric with respect to gamma, the circle, if this criteria is met. If the cross ratio of Z star from Z2, Z3, Z4 is equal to the conjugate of the cross ratio of Z, Z2, Z3, Z4. Is it clear? Is the statement clear?
ইয়েস।
Okay. So,
বাট ওয়েট, সিমেট্রিক উইথ রেসপেক্ট টু গামা মিন্স।
you are asking it pictorially, right?
ইয়া ইয়া।
We will go for that in a few minutes. Here, gamma is considered to be the mirror. Okay. So basically, Suppose this is your mirror, the x-axis, okay, x-axis and y-axis. If this is your mirror, then what is the image of this point? Say x plus iy with respect to this. This is x minus iy, right?
Yes.
That is its conjugate, right?
Yeah.
Now you can actually see if 3 points are in this line. Actually, if x-axis is your circle, x-axis is your gamma in C infinity, okay, then suppose there are 3 points on the x-axis, say 0, 1, infinity, okay, or maybe 2. I mean, real axis is the circle gamma which passes through the 3 points. Then actually you will be able to show that this criteria is satisfied. I mean, what I want to say is that x-axis is your gamma in, so then let z equals to x plus iy, then we can show z iy, comma z2 z3 z4. Okay, you can actually show this. So we have put z x plus iy instead of x minus iy, z star instead of this, and this is our z. So z, I mean x plus iy, x minus iy are symmetric with respect to x-axis. Okay, when x-axis is a mirror,
And the other points Z2, Z3, and Z4
are
on
real
the.
points, are real points. You can actually put, you actually
So
can,
Z2 equals to Z2 bar.
yes,
Okay.
of course. So you can actually you can see this. You can compute it. You know the cross ratio, right? Like z minus z2, those. You can compute it and see. So basically, they are extending this idea that when the mirror is not the x-axis or not a straight line, if the mirror is a circle, then what should be? For an example, suppose this is a mirror, okay, and you are outside it, and this is an object. Then the light should be like here, right? The image should be somewhere here. Okay. So now they are seeing a few things, like suppose gamma is a circle, like gamma is defined by this. R is a finite. Gamma is a circle centered at centered at A, and a finite radius. Z2, Z3, Z4 are distinct points in gamma, and omega star be symmetric points. Okay. Now see what they are doing. Then by the definition we can write this line that omega star Z2, Z3, Z4 is omega Z2, Z3, Z4 whole bar. Okay. Do you understand why these two lines are equal? Why this is equal to this? Why this is equal to this? Do you understand? Do you understand why these two lines are equal? Remember this result. For any Mobius transformation, remember this.
Oh, okay.
So they have taken the Mobius transformation z minus a. T z
Z
equals to
minus
z
A.
minus
Yeah.
a. Okay. So this happens. And this is a check by hand that this is actually this. I mean, I mean, what should be this? Z, Z2, Z3, Z4, whole bar. What should be this? Okay, let's write down. What was the cross ratio, by the way?
Z minus Z3 by Z2 minus Z3.
This was right.
Yeah.
So if you take whole bar, what do you get? Z bar minus Z3 bar by Z2 bar minus Z3 bar by Z2 bar minus Z4 bar by Z bar minus Z4. Right? That's nothing but Z bar, Z3 bar, sorry, Z2 bar, Z3 bar, Z4 bar. Isn't it? Here.
Yeah.
So by that we write this line. Okay. Now, what is Z? Now see, Z2, Z3, Z4 are on that line, right? On that circle, right? So we can write this, right? They have just
Okay.
written this. That this is R square by this. They have written this. Okay.
Mm.
Now, this is how this line comes. Now, from this line to this line, we are again that using that TZ criteria, like Z2, Z3, Z, Z2, Z3, Z4 is, as we said, TZ2, the cross ratio of TZ2, TZ3, TZ4, right? Here they have taken TZ to be R square by Z. Okay, so we get this.
Okay.
Here again TZ is Z plus A. Okay, so see what have they received, what they have got, and you will be actually stunned by the result. So what do we get? Since Mobius transformation is a one-to-one map, we can write this, right? We can write this because this and this is equal, this thing and this thing is equal. So
Yeah.
by that we mean this, right? So by that this we mean this, sorry, right? Right.
Yeah.
Now see, so that's the main thing we wanted. That is the result. That's how you compute the. So now it's quite easy, right? If you have omega, you can just compute omega star by this equation, na? By this equation, you
Yeah.
are computing omega star. Okay. So you were saying what is the geometric intuition, right, Rahul? See, this is the geometric intuition. Your omega is here.
Mhm.
Okay, your omega is here. So this is a point. This is origin. So this is a tangent. Okay, and this is the uh, image of omega. Image, I mean, under the mirror circle. Okay, Pritam, clear?
Okay.
হ্যাঁ দাদা
Oh, clear now বলবে. Isn't it interesting? I just find it fascinating.
দাদা ডায়াগ্রামটায় আরেকবার একটু বলো। ওমেগা থেকে ট্যানজেন্ট থাকছে এ তে, আর সিটা কি এখানে? সিটা আচ্ছা পারপেন্ডিকুলার, এ থেকে সিটা
Yes,
পারপেন্ডিকুলার,
yes, yes.
তারপর ওমেগাটা
No, we have actually, see, we actually have a circle and omega here. Okay, we are trying to find out the image of omega under the mirror this. Okay, when the reflection is taken by the mirror. So what we are doing is we are saying this is the mean. This is omega star. Okay.
আচ্ছা আচ্ছা ঠিক আছে।
This is A and this is omega star. So now you can check that actually this thing
দাদা মিরারটা কোনটা বললে?
mirror, the circle is the mirror. The circle is the mirror. We are actually looking for an image, a reflection of omega with respect to the mirror being the circle. Clear?
হ্যাঁ।
This is very very interesting actually. I find, I mean, the geometry in complex is beautiful. So what was our relation, by the way? The distance between this, that is this thing, okay, into the distance between omega bar and a bar, that is r square, where r is the radius of the circle. Okay. Okay. If gamma is a straight line, if gamma is a straight line, I mean, if the circle is a straight line, we saw that every circle was a circle in Riemann surface, Riemann sphere, and every straight line was a great circle in Riemann sphere, right? In the previous class,
Yeah.
we saw that from every. I think we did this. This was our
From Stein Sagarich.
from Shakarchi. I think we did it.
Yeah.
This was the plane, and this is our Riemann surface sitting here. And we saw that if a circle is here, the image is just a small circle here. But say there is a straight line, then actually under that map, like this actually becomes a great circle, right? Passing through the North Pole and the South Pole. Or maybe a great circle is a circle whose radius is same as the radius of the
Sphere.
So now they are saying, suppose gamma is a straight line, so they are choosing Z2, Z3, Z4 over gamma. So they are saying put Z4 equals to infinity and Z4 equals to infinity they are putting, and Z2, Z3 belongs to gamma. Now see what they are doing. So this is a straight line, right? This is omega. So what should be omega star? Omega star should be at same distance from the straight line as omega is. This distance should be equal, like we do in normal mirrors. The distance of the reflection is equal to the distance of the object from the mirror, right?
Yeah.
So see, that's what they are doing. They are saying that this is our equation of the Mobius transformation. Because Z4 is infinity, we get back this form. Remember, when Z4 was infinity, the cross ratio looked like this. Yes, when Z4 was infinity, the cross ratio looked like this. So that's what we are looking at right now. This is how the cross ratio looks like. If Z3 is infinity, then Z3 bar is of course also infinity. So after simplifying, you get this. Okay. Okay. That is distance from Z3, distance from omega of Z3, distance from omega star to Z3 is same. Okay. So by this, you can actually, from this equation, they have taken the imaginary parts. Okay. Imaginary part of this, that is imaginary part of this, that is minus imaginary part of this. Because imaginary part of Z is minus imaginary part of Z bar. So omega star lies on the opposite side of omega. That's what I mean. Why did they do it? See, the imaginary part of omega star minus this is minus of the imaginary part of omega star minus this. So omega and omega star lies in the other side of lies in the opposite side of the straight line. I mean, is it clear? I don't think it's clear. I mean, you will ask me why this relation. I mean, this relation is clear, right? This relation is just a computation. But why should this relation imply that omega and omega star in the opposite side? That should be your question, right? Is it convincing that why should it happen?
No.
Think about origin change. That's a hint. Think about origin change.
এমনি কমপ্লেক্স নাম্বারের যেটা এমনি রিপ্রেজেন্টেশন রিয়েল লাইনে সেটা দিয়ে হয়ে যাবে,
একদম
মানে এক্স কমা ওয়াই হলে একটা তো এক্স কমা মাইনাস ওয়াই হবে এরকম।
exactly. That's the hint. I mean, see what they are doing. They are just changing the origin to Z3, right? Okay. Hint is think this line as the y-axis. Okay. Let's. So that's what we have, right? I mean, Z2, Z3 is here, Z4 is somewhere there, omega is here, and omega star is here. আমি বলছি, what I am saying is, think that this gamma, think about this as y-axis. Now think.
মাইনাস ওয়াই অ্যাক্সিস বরাবর পাবো পয়েন্ট।
So if omega is x plus iy, what should be this? What should be this?
X minus IY.
মাইনাস ওয়াই
Is it x minus iy or minus x plus iy?
মানে ওখানে যে নিচের ছবিটা আঁকা ছিল সেইটা ঠিক আছে, উপরের ছবিটা মেলানো যাচ্ছে না। নিচে যেটা লিখেছো ওমেগা ওমেগা স্টার এটা ঠিক আছে, আর যদি ওপরের ছবিটা ট্রু হতে হয় তাহলে অ্যাক্সিস দুটোকে পাল্টে দিতে হবে।
No, no, just a minute. If omega, no, I mean, then z2 is of the form I into some y2. This is I into some y3, right? So let's see whether, so what is this? Omega star minus z3, right? X plus iy minus iy3, right? By z2 minus z3, that is iy2 minus iy3. And what was the other thing? Like x plus iy, this was minus x plus iy, sorry, x plus iy minus iy3 by iy2 minus all. So let's see what is the imaginary part of this. Okay, so multiply by I, there is ix minus y plus y3, and in the below we get multiplying by
minus
I
y2
plus
minus y2 plus y3.
y3, right?
হুম
So
তাহলে
here what
ইমাজিনারি পার্ট করবো
here
মাইনাস এক্স
imaginary part is
ওয়াই
minus x by
মাইনাস ওয়াই থ্রি
y2
প্লাস
y2
প্লাস
plus
ওয়াই থ্রি
y3, right? Okay, what is if you multiply by this
আই
y2
এক্স
minus y3,
প্লাস ওয়াই থ্রি নিচে
and what is here?
মাইনাস ওয়াই প্লাস ওয়াই থ্রি
Okay, understood why this is correct?
হ্যাঁ
Understood why this is correct?
Yeah.
So that's the Pritham, Arpon clear? Anisha clear?
হ্যাঁ
Actually, I was searching it pictorial.
Is it clear now?
Yeah. Calculation is
Pictorially, okay. See, I mean, when we are doing this, what you are actually doing, you are shifting the origin to z3, and then you are normalizing by z2 minus z3, right?
yeah.
So z3 is your 0 now, and dividing by z2 minus z3, you can treat this as 1. Okay.
Okay.
Okay. So symmetry principle. What is the symmetry principle? If a Mobius transformation T takes a circle gamma 1 onto gamma 2, then any pair of points which are symmetric with respect to gamma 2 are mapped by T onto a pair of points which are symmetric with respect to gamma 2. Okay. The statement is clear. Is the statement clear? That if omega and omega star are symmetric with respect to gamma 1 circle, then t omega and t omega star are symmetric with respect to the circle gamma 2. Okay, that's the statement.
Okay.
So let z2, z3, z4 belongs to gamma 1. Now what they are doing, like z star equals to z2 equals to z3 equals to z4, this is z, z2, z3, z4 whole bar. I mean, what they're assuming is, suppose z, z star are symmetric with respect to gamma 1. So then we get this equation. Now they are applying t. This is equal to this, right? This side is equal to this side, and this side is equal to this side. Now see, it's done. Just one line proof. If you are confused, have a look at it again. Okay. Now let's move on to another definition. Whether they are defining an orientation. Okay, I mean this is just a definition. I mean, see, when we say a circle is given an orientation, what we mean is that whether is this or this, right? This is something we mean. Whether this is on this side, I mean, or on this side, I mean, the orientation. I mean, how are we moving along the circle? So to put it in a rigorous way, basically, what you can do. So suppose you are going through this in this direction. So you can just say Z2, Z3 and Z4. Okay? That is you are going through this. And if you
or
want to
anti-clockwise.
just reverse the direction, you write Z4, Z3, Z2. Okay? So that's what they are doing here. But what I want to really emphasize on is this. The right hand side of the circle. Wait a minute. Yes. Is this clear? Do you know this result? That if Tz is equal to Az plus B by Cz plus D and Ad minus Bc is not equal to 0, then we can actually choose ABCD to be real. Are you familiar with this result?
No.
We can actually do it. So, what they are doing is they are computing Tz. Okay, so Tz is suppose there is a cross ratio Z2, Z3, Z4, which can be written in a Mobius transformation way, Az plus B by Cz plus D. I am just reading through this, okay. And Tz is this, Az plus B by Cz bar plus D, Cz plus D modulus of square. AC mod Z bar square, this. Just after computing, they are getting this, okay.
Okay.
Computations you can check. So if AD minus BC is greater than 0, then this implies Z belongs to, is this line clear? If AD minus BC is greater than 0, then all those Z for which this imaginary part of this TZ is real is basically if imaginary part of Z is greater than 0, right? Right? Because
Yeah.
imaginary part of 0, if this is greater than 0, this is if and only if imz is greater than 0. And this is less than, okay. So these two lines are clear, right?
Yes.
Pritam, Anisha, these two lines should be clear. I mean, these are
हाँ
pretty
हाँ
basic, right?
হ্যাঁ হ্যাঁ
If
Uh,
gamma is an
এটা
arbitrary
ঠিক আছে
circle, let Z2, Z3, Z4 belongs to a tau. For any Mobius transformation we have, this is Z, Z2, Z3, Z4 and is equal to this. Now, they are saying that they are defining two sets. They are saying these two sets are equal. Okay. All those Z for which imaginary part of intercross ratio is greater than 0. is basically same as all those z for which the imaginary part of sz, sz2, sz3, sz4 is greater than 0. That is also same at for which s inverse that thing is 0. That thing is greater than 0. They are saying these three sets are similar, exactly same. Okay. So I will give you say 5 minutes. Just go through this checking. I'm giving you 5 minutes. Go through this checking. We are doing it for a reason. This is not just doing for the sake of doing it, because we will go to a similar result, which is very important. That I was saying you that the right side of a circle is mapped to the right side of another circle by Mobius transformation. That's why you need this computation. See this, you have 3 to 4 minutes. You can actually do it on pen and paper. So you have gone through this, right?
ফার্স্টে লাইন এটা লেট ওমেগা ইকুয়াল টু এস ইনভার্স জেড লেখা আছে তো? ঠিক আছে।
Okay. So one thing I think you should have noticed, that this thing, the cross ratio, is basically, the cross ratio is positive, the imaginary part of the cross ratio is positive if this is S inverse of upper half plane or lower half plane, depending on AD minus BC is negative or positive, right? So we are defining the right hand side and left hand side. Okay, suppose Z2, Z3, Z4 is an orientation on omega, I mean on gamma, where
So
gamma is a circle.
if imaginary part is positive, then it is upper half plane.
Or lower half
The
plane,
inverse.
depending on the sign of the AD minus BC.
Okay.
See, the important part is that suppose AD minus BC is positive, then it cannot happen that for some points of upper half plane and some points of lower half plane, the imaginary part of the cross ratio is positive and or negative. It either sends the whole upper half plane or either sends the whole lower half plane to the positive or the negative side. That is the significance here. Look at it carefully. What does it say? What does the statement say? That Z, all the Z for which the cross ratio is positive is either pre-image of the upper half plane or pre-image of the lower half plane, but it can't be like both. I mean, say under the same Mobius transformation, it cannot be like it sends some Z from the upper half plane and some to the cross ratio where it is positive, and also some Z from the lower half plane. No, it cannot do that. It will either send the whole upper half plane to the right hand side or the whole lower half plane to the right hand side. First, let's define what is the right hand side or what is the left hand side. See, this is the definition of right hand side. If Z2, Z3, Z4 are any 2 points or any 3 points on a circle, then they are defining this to be the right hand side and defining this to be the right hand side, the left hand side. Okay. So what does this mean? This means that the whole right hand side, I mean the whole upper half plane, is mapped into the right side or the left side, right? It can't be like some part of the upper half plane is mapped into the right hand side and some part of the upper half plane is mapped into the left hand side. No, that cannot happen. That's the significance of this result. So suppose you are given a Mobius transformation with AD minus BC not equal to 0, and suppose they are asking you whether the upper half plane is mapped into the right hand side or the left hand side. So it's enough to check for just one point from upper half plane. You don't have to check for all the points. Okay, you don't have to prove it. You can just check for one point of the upper half plane and conclude that the whole upper half plane will be mapped to the right hand side. That's the significance of this result.
Okay.
প্রীতম বোঝা গেছে? প্রীতম, অনিশা?
হ্যাঁ,
Okay. Now let's move on to the orientation principle. What the orientation principle says, like say gamma 1 and gamma 2 be two circles. Let the gamma 1 and gamma 2 be two circles, and T be a Mobius transformation which sends gamma 1 to gamma 2 and Z2, Z3, Z4 be an orientation of gamma 1. Then T takes the right hand side of and the left hand side of gamma 1 onto the right hand side and the left hand side of gamma 2. Understood? The right hand side and left hand side of gamma 1 and gamma 2 is defined as above. Okay. Okay. This is the definition of a right hand side and a left hand side. Okay.
ঠিক
We
আছে
will soon see. One thing is there. We will soon see why this is defined as the right hand side and why this is defined as the left hand side. We will soon see it. I mean, in this class actually. We will see that in a moment. So suppose the right hand side of gamma 1 with respect to z3, z4, z4 is this, right? This is the right hand side. But what was this? This was T inverse this, right? From the previous checking. They are just
Yeah.
taking T instead of S. Okay. Yes, there it is. They are just checking these equalities. And they have taken T instead of S. These three they are using. These three. So this is T inverse this. So the right hand side of T2 with respect to Tz to Tz3 is this. Now, if omega belongs to A1, then omega is T inverse Z0 for some Z0, and imaginary part of this is greater than 0. Omega belongs to A1, right? So this means omega belongs to this. So this means omega is basically T inverse from something inside this. So T omega is Z0. Now they have put in this, you put T omega instead of Z0. This means T omega belongs to Z2, A2, right? So that's it. A2 was the right hand side of the T2, isn't it? A2 was right hand side of T2, right? This is A2, which is right hand side of SZ2, SZ3, SZ4.
Yeah.
Oh, Pritam, don't be quiet if you are not getting it. Now this is
হ্যাঁ দাদা ঠিক আছে
this discussion is very important. Okay, they are taking I0 minus I. Okay, so this is the circle. This is the circle. Like y-axis is the circle. So the cross ratio is like this. See this calculation, and I will show you actually two things. See these two calculations. These two calculations. Please see this. See this page. You have 2 to 3 minutes. See this page, and I will show you actually how magical this is. Okay.
Yes.
Okay. Now this is very important. See this. As you can see, suppose you are given 3 points, okay, on a circle. Suppose you are given it in an MCQ exam like TIFR, like NET. As you can see, these calculations can be very tedious, right? There is a big chance of silly mistake. So what do? See, suppose the orientation is this. So you are going from minus I to 0 to I. So suppose you are a human being, you are going by this path, okay? So what is your right hand side? You are a human being going through
Positive
going in that
x
direction.
axis.
So what is your right hand side? This part, right? And by our definition also, you can see this is the right hand side. Okay. See. No, this is something. Oh, this is okay. So see what this tells you, that this is the right hand side, like the one we are seeing here. Pritam, is the tree clear?
Yes.
Just go from I to 0 to minus I to 0 to y, and see which is your right hand side. And let's check it again. Suppose you are given another orientation, minus I 1 I, right? Minus I 1 I, minus I minus 1 I, right? So where are they situated? So minus I, right, 1 and I, right? So there is a circle, right, which passes through this 3 point, right? Right, this is your mirror. So you are going
Yeah.
from minus I, oh sorry, this was minus 1, sorry, this is minus 1, right? This is minus 1, right? So this is C. You are going from minus I to minus 1 and to I, right? So suppose this is the human being. What is his right hand side? Inside of the circle, right? He is going from minus I to minus 1 to I. Suppose this is a circular park. You are going through the boundary of the park. What is your right hand side? Inside the park?
Yeah.
If you are going in this axis, and see, that's what they have, I think, come across. Mod z such that mod z square is greater than 1. Plus 2 is it? What is this? Is it clear here? So z square is greater than this, right? So what is z square? Suppose z is x plus iy, okay? So what is mod z square? That is x square plus y square is greater than 1 plus, what is this? Twice imaginary part of z, that is 2x, right? Right?
Yeah.
So if you take, no, 1 you can't take at this side. Did I make some mistake?
To y. I
To y. But did I make some mistake here? Just a minute. We are about to see a few more examples. Just a minute. Give me a second. I think I have messed up this calculation here. Just give me a minute. Again, you see, if you are taking this direction I0 minus I, this means you are going from to I, you are going from I to 0 to minus I, right? So you are a human being, you are going from this side. So this is your right hand side, right?
Yeah.
And there are other examples also. There were other examples. I think I have messed up these calculations. Please calculate it properly. This calculation. I think there is some silly mistake in this calculation. Yes, there is a correct calculation. Now see, they are going from -1 to I to 1, right? So what is your right hand side? You are going from -1 to I to 1. This is your right hand side inside the circle, right? So after calculation, you see what they have found. Yes, this is. See, mod z square is minus 1. Mod z square is less than 1. So that's inside the circle. Okay. I'm trying to see whether there are another examples. Okay. They are trying to find out the right hand side with respect to this. Minus infinity to I to minus I. Okay. So they are coming from this. Okay. Here is minus infinity. Somewhere here. Oh, no. Okay. This is a very good example. See, they are going from minus infinity to I to minus I. So can you please tell me what should be your right hand side? They are going from minus infinity to I to minus I. So how should they move? They are going from below. Okay, understood. I mean, think is as a circle. Like they are going from minus infinity to I to minus I. This part
Then
I
outside
think,
of the circle.
yes. I mean, suppose this is your minus infinity is somewhere here, I is here, and minus I is here, right? So you are thinking, how can we go from minus I to I directly without reaching
Assuming
minus I?
a spiral path.
Exactly. Assume that this y-axis to be a spiral. So basically, imagine this Riemann surface again, Riemann circle again. So what is y-axis there? It's like this. So infinity and minus infinity will be both glued to this point, north pole, because this understood. The minus infinity and the infinity, they will be both glued to that north pole, right? So you are going from minus infinity to I here and
Yeah.
to minus I here. So what is your right hand side? This part, right? This part. Clear? Anisha, Pritam, clear? This is the part.
হ্যাঁ দাদা
This part.
হ্যাঁ
Isn't it very useful?
Yes.
I find it extremely useful because see, these nobody has taught me this. This is just my observation. And once I said this to my professor, Shlina also knows him. So he said me, you might have a point, that I might have a point, because mathematicians are not chemists, that they will actually name the same object in 4 different ways. So every name is well defined. So the right hand side is a right hand side for a reason.
Yeah, we got that reason.
Okay, but what I will tell you is that please check this calculation. Okay, please check this calculation. I think I have made some mistake here. This minus I minus 1 I, please check this calculation at home. So Mobius transformation, I have a few more things to say. Just let me open Shakarji. প্রিয়দর্শিনী, তুই কিন্তু বললি না তোর টাইমিংটা নিয়ে, সুবিধা অসুবিধা কিছুই বললি না। 9:30 থেকে সুবিধা অসুবিধা কিছুই বললি না। So this is another thing, like every automorphism from a disk to disk is of this form. Okay, let's see the statement first. Proof of Riemann mapping theorem, no. Where is the statement? See, the first, to me, the first stunning fact is that why is every automorphism from disk to disk should be a Mobius transformation, let alone of this form. Let alone of this form, why should every automorphism from a disk to a disk should be a Mobius transformation? But that's the case. Okay. Just a minute. Just give me a minute. See, this result is so beautiful actually. Every automorphism from the disk to disk is of this form. Once you are told that it is a Mobius transformation, you can probably find out that how this alpha and alpha bar works. That's fine. But why should every automorphism of the disk be a Mobius transformation? Orientation of rotation, okay, we know that. And similarly, for every automorphism of the upper half plane is basically of this form.
তাহলে এখনো পর্যন্ত যে অটোমর্ফিজম গুলো নিয়ে আমরা কাজ করছি সেটা শুধু সি ইনফিনিটির উপর। এখন যে রেজাল্টগুলো তুমি দেখাচ্ছ সেগুলো জাস্ট কিছু পার্টিকুলার অবজেক্টকে ধরে ধরে, যেমন ডিস্ক, আপার হাফ প্লেন।
But yeah, actually where the best thing is that they will ask you to show that whether an automorphism exists between the upper half plane and the disk. Okay, those are the interesting problems.
কনস্ট্রাক্ট করতেও দিতে পারে, তাই তো?
Yes. What D2OD? But I am not seeing the problems here actually. Yeah, this is the theorem. Takes the form Fn. Every automorphism is of the form Az plus B by Bz plus D, where A, B, C, D are real. So for upper half plane, this is like this. Next 4 or 5 classes that we have will be regarding problem solving, because we have actually completed the theory part. But first let me show how to compute a Mobius map T from upper half plane to D. So first of all, what is the upper half plane? This is this, right? And what is the disk? This is this. So first of all, we notice that let's try to think about how can we put this upper half plane to this. Okay, how can we put this upper half plane inside the disk? Okay, so my trick will be fix 3 points here. Okay, so you are going in this direction, so your left hand side is this, that should be the left hand side of this circle inside. So go from 1 to I to minus I to minus 1. Okay, so this is your left hand side when you are going from this direction to this direction, and this is your right left hand side. So you know that there is a Mobius transformation T which sends 1 to minus 1 to minus 1, no, minus 1 to 1, I to 0, and 1 to minus 1, right? This is the Mobius transformation that we want. isn't it? That's the Mobius transformation that we want, right? Which sends I to 0. You have seen that, I mean, for any two
Yeah.
circles, gamma 1 and this is gamma 2, there is a Mobius transformation that sends gamma 1 to gamma 2. We are trying to come up with a single Mobius transformation. So we are going to say that send -1 to 1, 0 to I, and 1 to -1. This should be opposite. Can you come up with this Mobius transformation? Can you come up with this? You can actually just do this. Suppose Tz is Az plus B by Cz plus D. Just compute it. What is T of 0? T of 0 should be I's, right? So put T of 0, that is B by D should be I. Put T of -1, that is A minus A plus B by minus C plus D is equal to 1, and T of 1 is A plus B by C plus D, it is -1. We were seeing something, I guess. Where did that theorem go? Okay. See, there is another way. You can actually use it using cross ratio, okay? You remember how did we compute this using cross ratio? If you remember that we actually have done the similar thing. That I think in our very first class. That is actually a very efficient method. Yes. If Z2, Z3 is distinct points in C infinity and distinct points, does there exist a Mobius transformation C such that this is happened? So this is how we constructed, right? And you know Tz at Mz. So basically, this is the way to do it, okay? This is the way to do it. Like Tz you construct, Mz you construct, compute M inverse T. We are just trying to use a shortcut. So B is Di, right? Put it here and try to solve this. You will come up with an equation. Okay? Shlina, okay?
হ্যাঁ দাদা
So that's how you do it. The inverse of this map actually sends the disk to upper half plane. Okay, that's it for today. So in the next class we will discuss problems. In next, actually, suppose 4 or 5 classes that we have, actually one will be off due to puja vacation probably.